In this section, we'll cover how to solve rational equations. A rational expression is a fraction of two polynomials. Some examples of rational expressions are the following: x plus 1 divided by x squared minus 2, 1 over x minus 7, and 4 over x squared minus 10x. One other one that we could see would be 1 over 3x plus 5 over 2x. We say that an equation is a rational equation if it has at least one rational expression on one side of the equal sign. So there's a standard method on how to solve these equations, and we'll generally follow this method that comes from the book. The first step is just to factor all the denominators. Then find and exclude all values that make the denominator 0. The reason why we do this is because if a denominator is 0 in a fraction, then it's undefined. Then we want to find the least common denominator, multiply the entire equation by the least common denominator. Finally, from here, we can just solve the equation. While this method will always work, we won't always follow this method in the next few examples. This is just a general outline of how to do it. In example 7, we want to solve the following rational equation. So let's do this by following the steps that we just established. So number 1, we want to factor all the denominators. In this case, there's nothing to factor, so we're going to move on to step number 2. And here we want to find and exclude all values that make the denominator 0. So the value that we'll be excluding this time is x is equal to 0. Because if we plug in 0 into this equation, we'll get a 0 on the left-hand side that's in the denominator and a 0 on the right-hand side that's in the denominator, and that's not well defined. Now we want to find the least common denominator. And recall, the least common denominator is the smallest number that can be a common denominator for a set of fractions. And to find the least common denominator, we just need to find the lowest common multiple of the denominators. So for example, here we have a 2x for a denominator, we have a 4 for a denominator, and we have a 6x for a denominator. This is saying that we need a 2x, this is saying we need two 2's, and this is saying we need a 3, a 2, and an x. So take all the unique parts of each of these. Here we need a 2 and we need an x. Here we need two 2's, so we'll add in a 2 to the last set. And since we already have in our green set a 2x, we just need a 3. So the least common denominator that we'll have here is a 3 times a 2 times a 2x, which is 4 times 3, 12x. So multiply both sides of our equation by 12x, and we'll get 12x times 2 divided by 2x is equal to a 12x times a 1 divided by 4 minus 1 divided by 6x. Simplifying this, this becomes 12 is equal to x times 3 minus 2. Adding 2 to both sides, we get 14 divided by 3 is equal to x. And this is our solution. Let's look at one more example, example 8. And we want to go ahead and solve the following rational equation: -3 2x plus 1 is equal to 4 divided by 3x plus 1. First, let's go ahead and exclude anything that makes the denominators equal to 0. So set the denominators equal to 0. 2x plus 1 is equal to 0, and 3x plus 1 is equal to 0. Solving the first one, we see that x is equal to a -1/2, and solving the second one, we see that x is equal to a -1/3. And so what this is telling us is that we want to exclude these values here. So x cannot be equal to a -1/2 as a solution, and x cannot be equal to a -1/3 for a solution. Now we can solve this rational equation a slightly different way. Instead of finding the least common denominator, let's multiply both sides by 3x plus 1 and both sides by 2x plus 1. So we're cross-multiplying. What we get is a -3 times a 3x plus 1 is equal to 4 times 2x plus 1. Simplifying this, we get negative 9x minus 3 is equal to 8x plus 4. From here, we just need to solve this equation. Subtracting 8x from both sides and adding 3 to both sides, we'll get negative 17x is equal to 7. So x is equal to a negative 7 divided by 17.